Hi, hello everyone. Good evening. How are you all? Cool. Okay, guys, let me know I'm an audible properly and my screen is visible to all of you properly. I hope, right? Just do text me in a chat box. Okay, is everything is clear right from my end? Okay, cool. Okay, guys, once again, welcome to all of you to this class. Okay, this is Sham, and today we are going to start with a new chapter that is the autumn, right? What is this autumn? Right, from this point we're going to start, and majorly autumn is not a single chapter. Along with one more chapter is assign means together with this chapter we call it one as an nuclei. Correct now? Nuclei. Okay, and then moreover from this two combination chapter here we can expect minimum two questions in JE and NEET. Especially in NEET, definitely two question will become, especially in NEET, two question you can easily crack from this chapter. Okay, chapter is not too hard, okay, but you need to know about the things which are coming under this chapter. Okay, concept तो बहुत लंबा concept नहीं है, छोटा छोटा है, but you need to remember a lot because in this chapter especially we are calculating while coming to the calculation perspective. Okay, you need to calculate a lot, like so many digits values you need to calculate, like 1.0008765 इसको multiply करना है ऐसी और एक value को. Okay, that's why in this chapter you're going to dedicate your most of your hard work. Okay, you need to make lot of hard work towards the practice towards the solving problems. Okay, you can easily identify the problem from which concept it is arriving. That is what should. Okay. Okay, चलो start करते हैं आज का class. Right. Okay, autumn से start करते हैं हम. Okay, in this chapter actually especially we are going to deal with two topics. Just a minute. What are the topics which we are going to deal here? First I will tell you. First one is that Rutherford alpha scattering experiment. This is the first point which we are going to discuss. Second point, distance of closest approach. What is the meaning of this distance of closest approach? And impact parameter. Impact parameter. These are the three major concepts which we are going to discuss in this today class. Clear? Let's start the session. Let us start the session. Quickly say in a chat box yes, like that. Yes. Okay, let's start with a chapter with an empty box. क्या है इंट्रोडक्शन? इंट्रोडक्शन में क्या बताता हूँ ना, आई नीड टू नो अबाउट व्हाट इज द मीनिंग ऑफ ऑटम. ऑटम क्या है? कोई बता सकते हैं क्या ऑटम क्या है? व्हाट इज द मीनिंग ऑफ ऑटम और हाउ यू नो अबाउट द ऑटम? Yes, that's the definition, right? Let's go through the little bit information about atom. Just imagine I have one matter. Matter पता है ना? कौन सा matter? Just imagine मेरे पास एक matter है. Okay, this is the matter. It is made up of n number of particles. N number of particles. Okay, what I will do now? I will suggest one of my student to this math. I will going to give this matter to one of my student. I'm going to suggest him that try to make pieces of this atom. Okay, let break this atom like that. I will going to suggest. What he will do? Obviously, he will going to break this one to two parts. Okay, two parts हो गया. Two part में आधा part इधर है, आधा part मैंने नहीं ले रहा. Again, I'm going to tell him that again break this. Again, he will be break. After then, I'm not going to take this part. Kitna part mil gaya? Correct na? Chota sa part. Again, I will tell him to that break this matter. Again, he is breaking. Again, he is breaking होने के वजह से until he will get one small particle. At one certain condition, he is getting one small particle. Correct now? Small particle मिलता है. Now, this is the smallest particle. He can't able to break this particle through his hand. Now, what I will do now? I will give the equipments what he required to break this particle. Micro equipments. I'm going to provide him. Again, he start to do. Again, he break this particle to another one piece like this chota sa. Again, he took and again he break and again he break down. Finally, एक particle आ गया इस समय भी. देखो इधर इधर एक पार्टिकल दिख रहा है ना, ये कहाँ गया? देखो इधर बहुत छोटा सा पार्टिकल है इधर. करेक्ट. This is a particle we obtained at a final point. From this point onwards, we can't able to break this particle further. Indistinguishable particle, we will say this one. What is that? Indistinguishable particle of this matter. Of this matter. Indistinguishable. Correct? Jane, we agree. Is there any problem? ओके. देखो इधर एक पार्टिकल है ना, थोड़ा सा छोटा सा पार्टिकल. That छोटा सा पार्टिकल we can't able to further distinguish means further we can't able to break, right? That particle of this matter we called atom. Correct? सही है ना? आटम क्या होता है पता हो गया ना? आटम है it's an finest particle we can't able to break further of the matter. We call that one as an atom. Clear? Guys, are you okay with? Are you okay, right? Yes. Good. Okay, atom हो गया. Correct ना? Atom के अंदर क्या क्या होता है? Let me know. Now we got to know about one thing. Atom is a smallest particle of this matter. It is an indivisible one. Correct ना? Okay. Suppose मान लो ये atom को, ये ही था हमारा atom. Correct ना? ये atom को इतना बड़ा से लिख दिया मैंने. Okay. Now tell me that what are the constituents present in this atom? Yes. Good. First point होता है proton. Right now, next one electron. Next one neutron. Okay, these are all the things which we are going to discuss in a nuclei. Okay, but we have to know about how the structure of the atom is present. What are the things or elements present in this atom? Correct ना? First, I'm going to tell you one more thing here. First है ना, atom को find out कर दिया. वो है हमारा Thomson, J.J. Thomson. You know this theory, right? Pump pudding और watermelon का कहानी पता है ना? Right? A watermelon है means watermelon के अंदर seeds होता है ना? We consider that one as watermelon as we consider as an atom. उसका अंदर seeds होता है ना? Seeds. We consider those seeds as an electron. Actually, here he told that the seeds. Actually, atom के अंदर positive charge भी होता है, negative charge भी होता है. But what he explained, actually positive charges and negative charges are arranged in random throughout the atom. Like that he explained. But due to this explanation, it will not given a complete idea about the atom. That's why this theory has been failed. at this at the time only. Okay, first the discovery of atom made by the J.J. Thomson. Okay, किसका कहानी? वाटरमेलन का, करेक्ट ना? वाटरमेलन के अंदर क्या क्या होता है? पॉजिटिव चार्जेस एंड नेगेटिव चार्जेस लाइक अ सीड्स प्रेजेंट इन अ वाटरमेलन एटम के अंदर. ओके, बट दे अरेंज्ड इन अ रैंडम मैनर. Seeds are arranged in watermelon random order, no, right? Like that. Okay, and he gave a current explanation also, one that number of positive ions present in the number of, that is fundamental particle are there, no, positive charges and negative charges, they are equal also, he said, but the arrangement of fundamental particle inside the atom he doesn't explain in a proper way. That's why this theory leads to find. Clear? Majorly guys, in this chapter atom mein we are going to discuss about three scientist theories. First one is that already over, that is J.J. Thomson. J.J. Thomson. Second one is Rutherford. Okay, third one is Niels Bohr. These three people's kahani only we are going to discuss in this whole chapter. Clear? Now the drawbacks from the J.J. Thomson, what are there? No, it is overcome from the Rutherford. क्या क्या बता दिया मैं बोलता हूँ. Okay, actually he explained the structure of an atom through an experiment. Experiment का नाम तो है Rutherford alpha scattering experiment. इन एक्सपेरिमेंट में, experimental arrangement में क्या क्या चीज है? First we will go to get to know that one. First one है source. This is the source. Okay, source actually which is emitting alpha particle. Note down this one. The source which is actually emitting alpha particle. Alpha particle means in table you know, right? Helium-24. Okay, this is also an alpha particle whose mass number is 4 and atomic number is, sorry, atomic mass number is 4 and yeah, atomic number Z value will be 2. Correct enough? Right. And in the same line where the now the source is emitting, no, this so emitted source को collimate करने के लिए means to move in a order arrangement, he make one small window with a lead box. This is actually made by lead. Either small portion. Okay, why the lead box that he kept means all the alpha particle which are coming, no, they are actually देखो इधर source में in all the direction they are emitting. In all direction these alpha particles are emitting. To move this all the alpha particle towards one side, actually he put a lead box. Okay, what it makes, actually it makes on straight path. Okay, and the alpha particles which are emerged from this lead box, no, after then he made to fall on a gold coil. कितना श्रीमंत था, gold coil ले लिया है इधर, correct ना? Right, gold foil ले लिया. Do you know why he took the gold foil to do this experiment? Is there anybody? If you know means please know, let me know through the chat box. Why he took the gold foil to do this experiment? It's highly malleable. Means we can stretch the gold foil. Foil means a sheet hota na. We can stretch until one single atom layer hota na. Up to that point, we can stretch this one. Right? That's why it took a gold foil for this alpha scattering experiment. मान लो एक gold है ना, इधर एक atom है, gold का atom, a single atom arrangement है, like this. Single layer का atom arrangement. Okay, now the emerged alpha particle from the source he made to fall on this gold foil. इधर fall हो गया. Then after he observed that almost all 99.8 percentage of all the alpha particles are scattered through this gold foil and fall on the screen. इधर screen है ना, screen इसके ऊपर fall हो गया, right? 99% scattered होके इधर fall हो गया, and the remaining percentage में remaining थोड़ा सा percentage they are scattered with some angle, small angle theta से scattered होता है. Okay, देखो इधर, these are the straight fallen. Okay, few of them are scattered through a small angle. These are only few, right? इधर भी देखो, with some angle theta. Few of the alpha particles are scattered with a small angle, and among 8,000 alpha particle में one alpha particle, it will be get reflected from this gold foil. These are all the experimental observation what actually Rutherford has noticed. Actually, I told one more thing here, screen. Screen है ना, a screen be made up by zinc sulfate material. Do you know why he took zinc sulfate? Zinc sulfate. Huh, zinc sulfate. Why? He can take iron also, no? Copper also. What is the advantages of zinc sulfate? Shining nature. Hey, hey. No, no, no. Actually, it is highly photosensitive material. We can say this one as an highly photosensitive material. Photosensitive material, I think you know, right? Last class we discussed about the photoelectric effect, right? ना उधर क्या हो रहा था एक्चुअली, एक फोटोसेंसिटिव मेटल के ऊपर इलेक्ट्रॉन मींस एनर्जी पास होता तो उधर फोटो इलेक्ट्रिक इफेक्ट टेक्स प्लेस होता था, मींस from that surface electrons start to eject, correct ना? Here are the same, here alpha particles when they are fallen इधर photo electric effect takes place होता है, वो photo electric effect take place होता है, means we can easily observe through one microscope. Call this one as a microscope. Okay, this is a traveling microscope, we can observe through this zinc screen. Okay, when you observe through this microscope from point to point everywhere, almost a maximum percentage of scattered electrons, scattered alpha particles are fallen in this region, means without scattered they enter. Few of them are came here. I will take our next color. Yes, only few percentage or make some angle, and one alpha particle in 8,000 are reflected back. Reflected back. Okay, this is what the experimental evidence. What he observed. From this point, he concluded that yes, a gold atom here means almost all 99 percentage of alpha particles scattered through it, means a atom है ना, alpha a atom, इसके अंदर consider, if it is a atom means इसके अंदर 99 percentage space is empty. He told that 99% of space is completely empty, correct ना? And few angles are reflected, means ये atom के अंदर कुछ है, रिफ्लेक्ट हो रहा है और थोड़ा एंगल क्रिएट हो रहा है, मींस like same charge will be present inside the atom. He had a one thought like that, means alpha particle means it's a positively charged, correct ना? Gold atom here reflecting the alpha particle means positive charges, something should be there inside the atom, that's why it is reflecting. That is a thing which came in the mind of Rutherford, correct ना? It leads to be that yes, इस atom के अंदर एक सेंटर है, ओके, वो सेंटर में क्या चीज है ना, वो पॉजिटिवली चार्ज है। he given a statement like that, ऑटम उसके सेंटर में एक समथिंग पॉजिटिव थिंग्स है, ओके, दो दैट्स व्हाई दे आर रिफ्लेक्टेड बैक। क्लियर? एंड yes, yes, good, good. Okay, this is leads to be development of positive charge present in an atom. Then afterwards, we call this positive charge space or positive charge region as an nuclei. Okay, this is a experimental evidence. We can clearly observe this one in the next figure. I will move to the next one. I think this is understood, right? The thing what I explained. Is it understood? Yes. We'll move to the next slide. देखो इधर, देखो, this is the lead box what it took actually. Okay, alpha particle scattering है था वो. This is a source. Okay, source को you can take bismuth. Okay, bismuth is a good source for alpha emitting source. Okay, when you switch it on, the alpha particles start to emit from this region. Okay, in front of that region exactly, in front of it, we place one gold thin foil. Okay, to scatter the ejected alpha particles. Okay, and after sulfate screen also to observe the scattering effect here. Clear enough? When this lead box emits the alpha particle, it start to move towards the thin gold foil. Correct now? Alpha beam. You may observe this simulation properly here. Okay, देखो इधर. Almost all particles they are scattered and fall on the screen. Correct now? Only few of them, only few means in already I told you that the number also one alpha particle in 8,000 it will be reflect back. Correct now? This is what actually explained by the Rutherford. One by one I will explain you, don't worry. Okay, and then देखो इधर, this is a gold atom. Correct ना, with positive charged nuclei. देखो, first thing when alpha particle came no from the source, alpha particle, this is a alpha particle from when it is mono, when it is away from the uh, nucleus. Nucleus इधर है, देखो इधर, this is the nucleus. The alpha particle which is approaching in the line of atom, okay, it is very far from the nucleus means without deviation it will be moving in this direction. As it is coming near, as it is coming near to the nuclei, instead of going in a straight line, देखो इधर, actually इसका path था इधर, in this direction it has to move, but it deviates through an angle theta. And further if it is come like this means again देखो इधर, this is the actual direction of the alpha particle, but क्या हो गया, it is deviated again. And further when it is coming very near to the nucleus, देखो इधर again इसका actual path इधर था, but it makes an angle theta this much. देखो इधर, when alpha particle velocities means alpha particle approaching towards the nuclei, okay, when it is very far away from the nucleus means without scattering it will be moving in a straight line. As it is approaching towards the nucleus, as it is approaching towards the nucleus, it is started to bend, means it is making some angle theta with respect to its original direction. Correct now? This is called this theta value we called as an scattering angle. What we will call scattering angle. देखो, as the distance coming closer to the positive nucleus, द स्कैटरिंग एंगल क्या हो रहा है, इंक्रीज हो रहा है। देखा ना, देखो और एक बार लिखता हूं, मैंने इधर शो करता हूं। दिस इज द फर्स्ट लाइन, एक्चुअली इसका पाथ था इधर, एंगल इट इज डिस्क्राइब्ड बाय दिस वन, दिस इज थीटा। सेकेंड पाथ इधर है, करेक्ट ना, देखो एंगल कितना बड़ा हो गया। एंड थर्ड वन इधर था, एंगल देखो कितना है, राइट। एज द डिस्टेंस which is coming decrease, the angle of scattering value keep on increases. And when exactly it approaching towards the nucleus like this, okay, it will exactly reflect back, means at this position it will trace us around 180 degree, 180 degree reverse back. Even it is not yet touched also this nucleus. Without touching that nucleus, it will be reflected back. And the position from where it is reflected back to the center of the nucleus, we call this one as an distance of closest approach. I will explain that one later, no worries. Okay. I have some other concept. I will explain this one later. Okay. As I again further it is moving downward direction. Alpha particles means not only they are projected in upper side. Okay. In all the points, alpha particles are present from here to here. If you want to consider for one gold atom, again it will become means again reflected angle increases. Again, देखो, right? Now it is the scattering angle goes on decreases. Correct now? I hope it is understood, right? Let me know through the chat box quickly. Is it understood? Yes. Cool. Great. Great. Okay. Next, we need to write one graph for the number of alpha particles scattered versus this impact parameter. So impact parameter distance. What is that impact parameter? देखो इधर. Here, from this is the first line of just a minute. Yes, this is the first line, है ना? This is the first line of alpha particle velocity. Okay, from this point to the central point, the distance is there, no? Some distance is there from the first velocity of the alpha particle direction. This is the first velocity of alpha particle distance to the, what is this? Central line. Central line velocity of alpha particle. Up to this point, there is a small distance. Correct? There is one of the small distance. We call this distance as an impact parameter B. In this letter, we will explain. Okay, here the thing is that देखो scattering angle versus number of particles scattered. This is what we are going to draw here from. Okay, already I told you that as a scattering angle increases means number of particles scattered is क्या होता है? Okay, I will tell you. Okay, no, I got answer. Decreases. Yes. Okay. हाँ, ये फिगर है ना, एक्चुअली ग्राफ को हम वो थियरी से एक्सप्लेन करना है. कैसे? ओके देखो, स्कैटरिंग एंगल बहुत कम है, स्कैटरिंग एंगल बहुत कम है मींस मैक्सिमम नंबर ऑफ पार्टिकल्स विल बी स्कैटर्ड. आर यू गेटिंग माय पॉइंट? इधर देखो, इधर इन दिस कहाँ हो गया? हाँ इधर देखो, इधर दिस इज सेंट्रल गोल्ड फॉइल, करेक्ट ना? इधर स्कैटरिंग एंगल कुछ भी नहीं है, मींस पैरेलल बीम कमिंग मींस मैक्सिमम नंबर ऑफ alpha particle will be scattered on the zinc plate in an exact position. Okay, as the angle increases, number of scattered particles also decreases. Correct now? As further increases, at more than 90, if you're going to reach, means the number of particles which are scattering here very much less. Correct now? This is what actually we have to draw in this uh, graph. I will explain you once again. No worries. ये जंप नहीं होता है एक स्क्रीन से दूसरा स्क्रीन पर. Yes, this is a scattering angle versus number of particles scattered. When zero angle tha means all means maximum number of particles are scattered through the gold foil, means maximum means zero angle में बहुत ज़्यादा होता है like this density. As the angle increases up to 90 degree, there are some scattering particles are we can get. Okay, here around 10 to the power of 7 you can take. Okay, here you can take 10 to the power of 1, 10 or below 10. When it is reaching the angle 90 degree, up to that point, some scattering particles will be available. Further, more than 90 degree, only few particles are scattered and reflected back. That is mentioned in less than 100 here, less than 10 number of particles scattered, and angle is more than 90. And if you're going to join all these lines, means you will get a curve like this. This is the graph actually which explains the scattering of alpha particle versus scattering angle, which is actually conducted by Rutherford alpha particle scattering experiment. Is it clear, right? Now, hope it is clear. Hey, thank you. Someone is there. Hey, Nandish. Hi. Which school you're from? Okay, cool. देखो इधर alpha particles actually they are coming towards this side. इधर एक positive charge है nucleus, gold का nucleus है. Due to that, इधर the particles are repelled back. Correct ना? इधर इन दोनों particle का बीच में force कितना था? What is the amount of force we need to calculate? Yes, we need to calculate. Yes, understood. Okay. How to calculate this one? Actually, either alpha particles also charged particles, and this center of the gold foil is now that is also actually uh, yes, bro. This is a first class. This is a first class, and this is a positively charged particle and nucleus. This is also charged one. Means, can you guys tell me that two charges are there here? Two charges are there. What kind of force can exist between these two charged particles? May I know? May I know what kind of force is exist between these two charged particles? Ha, no, 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 Priya. No. Yes, that's what I'm expecting the answer. This is a electrostatic force. Correct now? Electrostatic force will be exist between the two charges. Correct now? To say this electrostatic force, generally we know, right, one equation, electrostatic force EFP is equal to 1 over 4 pi epsilon naught Q1 Q2 upon R square. Correct now? This is what actually we are writing. Correct? Yes, of course. Here charges are there, no? Q1 and Q2. We need to replace these two charges by the alpha particle charge and as well as the gold nucleus charge. Clear hai na mera baat? And in that Q1 value will become Q1 means here charge of alpha particle. Alpha particle को charge कितना होता है? 2 electrons. Q actually alpha particle is nothing but helium, means helium-24, no? Helium-24 is the alpha particle. Correct? Helium-24. Either 2 electrons are there, 2 protons are there. That's why we are writing 2 as a charge of a helium. sorry, alpha particle. Correct now? And what is the charge of a nucleus? We don't know. The charge electron है उसका atomic number से multiply करते हैं, means Z into E we will write. Okay, Z into E. Substitute here the term. So okay, Q2 will become Z into E, and substitute these two things in this equation. Substitute करना है, substitute कर लो. Force कितना आता है देखो एक बार. Fe is equal to 1 by 4 pi epsilon. We can write like that only, 1 by 4 pi epsilon naught into Q1 Q2 means it is nothing but Q1A 2E and Q2A ZE, and divided by, don't forget to write the value of R square. Okay, this is what the force which is exists between an alpha particle and as well as the nucleus of this gold atom. Is it clear? Let me know through the chat box quickly. Okay. Yeah. Yes. Good. And if you have any doubt based on this one means, please do drop your doubts in the chat box. Okay. Next thing. After this, yeah, already I draw this one. देखो इधर, alpha particle nucleus helium atom carrying a charge of 2e, I told you that, and mass is equal to 4 times of the hydrogen atom, and it travels with a speed nearly 10 to the power of 4 meter per second. Please note on this one guys, 3 things which you need to note on. Alpha particle, उसका charge कितना है, 2 electron, and उसका mass 4 times of the hydrogen atom, it's nothing but 4 atomic unit. Okay, and it is traveling with a speed of 10 to the power of 4 meter per second. Just imagine, it's in 1000, right? That's why we are taking here alpha particles. Okay, next, what are the sources, what are the observations which have made by the Rutherford? Will list up here. Rutherford experiment में क्या लिया था actually, एक source of alpha particle लिया था ना. We can take this one also. Lead also you take, or else yeah, radon also you can take, no problem. Okay, so for the alpha particle, and bismuth is also one of the good thing for emitting the alpha particle. Bismuth is also good. Okay, bismuth का speed कितना होता है, 1.6 into 10 to the power of 7 meter per second. But if you want to take the radon means it will be 10 to the power of 4 meter per second. And thickness of the gold foil कितना था, 10 to the power of -6 meter. It is nothing but micrometer में था. That's why I told you that why we are taking the gold foil means it's highly malleable, means we can make this one in a single layer of the plate. Correct na? That's why. And coming to the next point, observation. First thing, most of the alpha particles passed through the gold foil. Correct na? I told you. Some of the alpha particles were scattered by only small angles of order of few degrees. Few degrees means very less amount of angle they are going to scatter. No need to worry. And few of alpha particle, 1 in 9,000. Okay, no worries. Actually, when I studying in a book, in that textbook reference book, they given 8,000. Here they given 9,000. Okay, no problem. Were deflected through a large angles greater than 90. Correct now? And some of them even refracted, retraced their path. That is, angle of reflection was 180 degree also. Correct now? These are the observation which is made by the Rutherford, right? And then conclusion. Conclusion क्या क्या दिया था? It indicates that most of the space in atom is empty. Means straight line move हो गया ना, इसलिए it told that most of means ತುಂಬಾ space ಏನಾಗಿದೆ empty ಆಗಿದೆ. Okay, second case क्या था? Alpha particles are scattered by only some angles. Few angles are in few angles they are scattering, means alpha particle being positively charged and heavy compared to the electron. Compared to the electron, it has heavy one. That's why only the deflected by heavy and positive region of the atom. Few of electrons also there, no, that's why they are reflected. Deflection. Deflection, where it is. Deflected means actually either gold foil tha. Most of the alpha particles pass through it, means actually they are scattered through it. Easily they can scatter through it. But deflected means instead of going in a straight way, due to the presence of force, न्यूक्लियस में पॉजिटिव चार्ज भी है, करेक्ट ना? ये अल्फा पार्टिकल्स आल्सो पॉजिटिव चार्ज. Instead of going straight, they take some angle. They take some angle from the original direction. That is called the deflected. Deflection direction. I hope it is understood, right, Priya? Yes, good. Where I'm, it indicates that positive charge and the most of the mass of the atom are concentrated at the center, is called nucleus. I told this one also, no worries. And alpha particles which travels towards the nucleus directly get retarded due to the Coulomb's force. I told this one also. Why it is not working, I don't know. Okay. Coulomb's force of repulsion and ultimately comes to rest and then fly off from the opposite direction. Huh. I forgot to tell one thing here. Why not? The next page I will explain that. Dekho. And they will ask that number of particles scattered in one unit length means a positive charge nucleus था, इधर alpha particles आने के वक्त में ज़्यादा ऐसे deflect हो गया, correct ना? If you are going to consider, if you will consider this length, you can call this one as an impact parameter. In this unit length में कितना alpha particles are scattered? You need to calculate sometime. In the sense of NEET and as well as JE question will be appear from this question, from this topic. How many number of particle will be deflected through unit length? Okay, you need to calculate through this formula. The formula is number of alpha particles scattered with some angle theta is inversely proportional to the 1 by sine to the power of 4 theta by 2. Note on this one. Note on this one. Okay, kya? This last point only. No need to write everything. Okay. The formula note down karo. Note down mari bega. N of theta alpha particle is inversely proportional to 1 divided by sine to the power of 4 theta by 2. Clear? Okay. Come to the next point. Distance of closest approach क्या होगा? देखो इधर सुनो. ये क्या है? Nucleus of a gold atom. Theta centermost particle is a gold atom. देखो यार, रुदरफोर्ड ने गोल्ड आटम के साथ एक्सपेरिमेंट किया है. नमको इन्नु काला बंदिला. ओके, ತೊಂದ್ರೆ ಇಲ್ಲ. Distance of closest approach gold atom ले लिया था. इधर when a particle approaching towards the nucleus exactly at the line of parameter, exactly at line of nucleus, okay, it will move in this direction and it will be returned back. Correct now? Observe here once again. Right? Even it is not yet touched that nucleus also. Here, this point, from this point to center of the nucleus, whatever the distance is there, no, we call this one as an R naught. R naught. This is we call as an distance of closest approach. कितना close आकर पीछे हो गए, ಎಷ್ಟು ಹತ್ರ ಬಂದು ಹಿಂದೆ ಹೋಯ್ತು. We need to calculate this one. We call this one as an distance of closest approach. Clear? Clear है ना ये बात? क्लियर रखो बेगा. देखो क्लियर ಆಯ್ತಾ ಇದು? Yes, good. Now we need to calculate this distance of closest approach, that is r naught value को calculate करना है. देखो. Yes, actually particle ಇಲ್ಲಿದೆ. From this point particles start to move towards the nucleus. When it is moving means what kind of energy present inside the particle? Let me know quickly. What is the what kind of, yes, good, kinetic energy present here. Correct now? Kinetic energy present inside the nucleus, so in the alpha particle. As it is moving towards the nucleus, at one certain point, at this point, last point में इसका velocity 0 होता है. When velocity will be 0 at this point, kinetic energy value also 0. Correct now? Kinetic energy value also becomes 0. But when it is moving towards the nucleus, kinetic energy value keep on decreases. Kinetic energy keep on decreases. Okay, second one. Here position also changing. Alpha particle पहले ये point में था, now consider B point में आ गया. Due to change in position, what kind of energy will be present? One more kind of energy is there. Kinetic energy के साथ साथ है होता है, ಯಾವಾಗಲೂ ಜೊತೆ ಜೊತೆ नहीं रहता है. That is what potential energy. Correct now? But when at the point A, potential energy is, yes, right here. Right here, guys. Potential energy is high, less here. When it is approaching towards the point B, potential energy will become maximum. Potential energy will become maximum. Means kinetic energy keep on decreases, means potential energy keep on increases. After reaching this point, particle will start to move in opposite direction. No. Now kinetic energy is increasing, potential energy again decreases. Why I'm telling this one? No, from this concept only we are going to evaluate the value of distance of closest approach. R naught value को from this point only we are going to evaluate. क्या है ना, concept simple है. Concept क्या है? इधर kinetic energy is converted into potential energy. Again potential energy is converted into kinetic energy. Means both the energies are same during the total traveling में same ही होता है total energy. Okay, either we need to consider first. Okay, definitely. Okay, wait. Okay, देखो इधर, this is alpha particle. Alpha particle is moving towards the nucleus and it will be come back. Okay, when in the initial point, if you're going to consider at the initial point में potential energy होता है, potential energy बहुत कम होता है, potential energy कम होता है. As it is moving towards, once again, just a minute. Okay, leave it. This is a point A. From point A से particle is moving. Okay, first thing is that when particle is moving means उसके साथ एक energy होता है. We call that energy as a kinetic energy. Right now, when the kinetic energy is moving towards the particle which is moving towards the nucleus, its velocity keep on decreases because here alpha particle is a positively charged particle. Either nucleus also positively charged particle. Alpha particle which is approaching towards the nucleus means a dono same kind of a charge, they should be repelled. That's why here the particle velocity will become less when it is approaching towards the nucleus, right? At the exact point of reflection, at this point velocity will become 0. Correct now? If velocity will become 0 means kinetic energy also becomes 0 because kinetic energy value will be of mv square. If v becomes 0 means kinetic energy value also becomes 0. Clear now? But when the value of v will become 0 at this position, due to change its position, potential energy value will be here maximum. पोटेंशियल एनर्जी क्या होता है, मैक्सिमम होता है. Okay, and after this reaching point B, the particle will start to move in opposite direction to the nucleus. When it start to move in this direction, means its velocity again keep on increases. Velocity increases. Correct now? Due to increasing in velocity, kinetic energy value also increases positively. But at this point, potential energy value will be decreases. Potential energy value will be decreases. Clear now? Meanwhile, total energy of the system will be same. Now क्या हो गया actually, kinetic energy converted as, sorry, potential energy, kinetic energy converted as an potential energy, and again potential energy converted as an kinetic energy. Energy conservation हो गया. From this point we can take kinetic energy is equal to potential energy. This is the condition. Okay, if you take this condition means kinetic energy का वैल्यू पता है आपको, क्या था kinetic energy, हाफ mv square. Potential energy लिखना है. Do you know guys what is the potential energy? Suddenly yes, we will get to know that potential energy means mgh. Don't write mgh here. Okay, potential energy means due to the charge we need to write potential voltage. पता है ना, इलेक्ट्रोस्टैटिक्स में इलेक्ट्रोस्टैटिक पोटेंशियल में बोल दिया था इसको, राइट? क्या होता है वो, इधर देखो, 1/, क्यों ऐसे हो रहा है मेरे साथ, पोटेंशियल ड्यू टू इलेक्ट्रोस्टैटिक फोर्स क्या आता है, 1/4πε0, 4πε0 Ze is a charge of a nucleus into 2e. It is nothing but charge of a alpha particle. Yes, right, right guys, and divided by r. R is the separation distance between them. This is we called as an potential energy. इसको equate करना. Here r is nothing but closest approach. We need to replace this one by r naught. And you take this r naught to left hand side and this kinetic energy to right hand side. Then we will get a final answer. Will be like this. 1/4πε0 इधर 2 ze square होता है. Clear ना? This is called the closest approach. How closely the alpha particle will come near the positively charged body and it will be reflected back. We can calculate it by using this equation. Clear now? Okay, good. Yes, we'll move to the next slide. Next slide. Yes, distance of closest approach है. Same है क्या? हाँ, okay, no problem. Next thing is that impact parameter. ये impact parameter क्या होता है? I already told you that. देखो इधर again, this is the nucleus. If alpha particle will be moving like this, suppose मान लो if alpha particle is moving very far distance from the nuclei, means without deviation, deflected, it will move like this in this direction. But as it is approaching towards the nucleus, it will not move in a straight path. Correct? It will be deflected through an angle theta. We call this process we called as here scattered. The alpha particle क्या हो गया? Scattered हो गया. Correct? From this point, this is the initial vector. If you're going to take this point, initial vector, right? Second one, you take r naught, where it is. R naught means it's the line of action, last point. क्या हो रहा है यार? Okay, this is a central line है ना? इधर तक distance कितना है? कितना distance है? We call this one as an impact parameter. Okay, this is, if you're going to consider this, the first line means from the first line to the central line. This is the central line. The distance between a central line to the first velocity vector. Or else if you're going to take the first velocity vector as this dotted line, what I draw now, this one means from this point to central line, the distance is there, no, we call that one as an impact parameter. Okay, impact parameter can also define that like this: the perpendicular distance of the velocity vector of the alpha particle, velocity vector of the alpha particle from the center of the nucleus when it is far away from the nucleus is known as the impact parameter. I told you, no, not only this line. Actually, if you're going to consider this line as a first velocity vector, if you consider this a first velocity vector, means from this point to up to this point, whatever the distance is there, no, we call this one also as an impact parameter. Clear enough? Hope it is clear. And next thing is that note on this formula. Actually, this is very important formula to calculate the impact parameter. Direct formula. Okay, formula क्या है? Impact parameter को we are going to write in the letter B. B represents here impact parameter. Okay, and Z represents atomic number. E is nothing but a charge of an electron and also alpha particle, both are same. And then cot theta by 2 divided by 4 pi epsilon naught into half m v square or u square. It's nothing but kinetic energy. You can write like this also: B is equal to k z e square. K is nothing but 1 by 4 pi epsilon into cot theta by 2 divided by kinetic energy. This is also formula for the impact parameter. Clear now? Hope it is clear. Let me know through the chat box quickly, guys. क्या हो गया? कुछ नहीं हो रहा है. अरे यार. Sure. Yes, good. And guys, one small sorry for this one. Here first one sentence है ना, so थोड़ा गो से देखो. For large value of b, cot theta by 2 is large and theta, the scattering angle is small. Means that guys, in theoretical part I explained this one. क्या है ना? This is nucleus means, okay. Impact parameter line is here, first line. Okay, as it is moving down means if it is come here means, okay, इसका impact parameter में angle तो बहुत कम होता है. देखो इधर कम होगा. If it is approaching exactly at center or थोड़ा center से means it will be scattered more. Means here it is saying that this impact parameter distance है ना, b value, as it is decreases means first line से center तक decrease हो रहा है means the value of scattering angle is increases. Hope it is understood. From first velocity vector से down आ रहा है means scattering lines means angle of scattering is more. Okay, and then for small value of b, cot theta by 2 also small, and theta, the scattering angle is large. I explained that one. Alpha particle close to nucleus, large deflection. Okay, देखो इधर third second point में in second point, alpha particle traveling close to the nucleus suffers larger deflection, and if it is passing, it means if it is striking exactly at the center of the nucleus means it will be reflect back. Maximum angle is 180 degree. इधर है, देखो. What we learn, no, those all things explained in this lines. Okay, no worries. I will send this PDF to in a group. Okay, you can take this one. It is enough, guys. Today, nothing is there. Okay, last point I'm going to dictate here. Clearing things. These are okay. What are the things which we learn in a Rutherford atomic model? First thing is that atom contains positively charged. We call that one as a nucleus. That's why the alpha particles are reflected back. Okay. Second thing is that the nucleus contains almost all of the mass, means maximum amount of mass is present inside the nucleus only. And it occupies by very small volume. Very small volume. Guys, just imagine that the nucleus size, if you're going to consider this is a cricket stadium. This is a cricket stadium. This much big atom is there means the nucleus will be in the size of cricket ball. क्रिकेट बॉल के साइज में न्यूक्लियस होता है मींस मैक्सिमम अमाउंट ऑफ मास विल बी ऑक्यूपाइड इन दिस बॉल क्लियर है ना रिमेनिंग ऑल द थिंग इज एम्प्टी okay bro football le lo but why I took cricket stadium means it is in a structure of round no that's why great football lover Nandish and the negatively charged electrons which are occupied most of the volume in the atom in a space remaining space mein negative charged atoms are there it says and the atom is most of all empty only space. Okay, these are all the conclusion which is given by the Rutherford and tomorrow onwards we are going to continue the same thing atom why the Rutherford theory will be failed and what will be the new evaluation towards the atom and few assumptions also we are going to take there. Okay, in the next class we are going to continue this one. Hey, even me too bro, I'm also volleyball lover. Okay, cool. Okay guys, we'll meet in a tomorrow class. Until then, take care. Bye bye. If you have any doubt means please drop your doubts in a chat box section. Nandish, from which school you are? Priya also, which school you both? I think she seems to be Hassan. Chikmagalur. Yes. Hassan, Vishal sir, Yashaswini, and then someone with, yeah, I got it. Okay, guys, we'll meet in the next class. Yes. Okay, we'll meet in a tomorrow class. Until, Nadish, who is from Chikmagalur? Nobody is there, bro. You are only CKM means. What is the full form of CKM? That's a Chikmagalur, right? Avanti Mendes, I don't know, bro. I don't know actually. Myself, Sham. That's a Sham. Okay. Okay. Okay, guys. Take care. Bye.